Welcome back to Bee Spice. In this session, we'll discuss about fire and gas system. So basically, we are going to talk about some outline about the fire and gas system in part 1. So in part 1, essentially what we are going to do, we are going to talk about detection, fire and gas detection partially, and the rest of the items will focus on part 2 in addition to the protection system also. Okay. So the agenda for this session is more on detection system, fire and gas detection system. Okay. In fact, one of our members actually, a subscriber asked for this. That's why I am uploading this. Okay. So fire and gas system. As we all know, fire and gas system monitors the plan for accidental fires and uncontrolled release of hydrocarbons. Right, friends? So it monitors the plan for accidental fires and uncontrolled release of hydrocarbons, predominantly in petrochemical and refinery establishment. So the main purpose of fire and gas system is to detect the fire and gas hazards wherever they are likely to occur in a plant and to alert the plant personnel and initiate preventive measures automatically or manually. So the main purpose is to detect the fire and gas hazards. Okay, so the fire and gas consist of field-mounted detection equipments, manual alarm station, logic control system for processing of signals, alarms, and display units, including miming. So this is the composition. So to sum up, fire and gas consist of field-mounted detection equipment. There are various, detectors which we will be talking in the subsequent slides. Manual alarm station and logic control system, and of course display units. So all fire and gas output shall be de-energized in normal condition. So that is the point, friends. All fire and gas output shall be de-energized in normal condition. Energized to trip. De-energized. Normally it will be de-energized in normal condition and energized to trip. Just remember. Okay. Right. So fire and gas system functionality. What is the main function? See, basically it receives the inputs from the detection system, okay, alarm system, and any other equipment related to fire protection and safety. Very simple, right? So it processes all the input signal in accordance with the applicable fire protection data sheets. Okay. So it initiates a output signal, alert the operator or plant personnel by audio and visual alarms, and activate fire protection system. These are the functions. And of course, it initiates shutdowns, either hardwired or communicated on data highway to other system panels such as, ESD, HVAC, safety and automation system, right? So the fire and gas consist of two subsystem, friends. Okay, one is the detection system and other is the protection system. So as I mentioned earlier, so the detection system we are going to cover partially in part 1 in this session, and the rest of the items in part 2 along with the protection system. So that is the agenda. So we'll go into the agenda. Okay. Now, detection system. Okay. Detection system used to protect the fire. Okay. Probably. Okay. What I want to say is, okay. So I'll just touch upon a bit on the detection system. Then I go into the individual items. Okay. So the detection system used to detect fire and hazards wherever they are likely to occur. Okay. So fire detection system. This is for all areas with a potential fire risk. Okay. So for the fire detection system, there are a lot of items actually. One is the smoke detectors. So if you talk about fire detection, this is for all areas with a potential fire risk. So under this, we have smoke detector. So under smoke detector, we have a HSSD. HSSD. So what is HSSD? Friends, one more point. I'm actually explaining more on each concepts. I'm explaining more orally. Okay. So here HSSD. HSSD is nothing but high sensitivity smoke detection system. Okay, so these are all advanced fire detection system designed to detect smoke at early stage, providing timely warning and to minimize the risk of fire damage. So that is the point. So again, to repeat, under fire detection system, I'm talking about smoke detector. Okay, under smoke detector, the one of the important item is HSSD, which is high sensitivity smoke detection. So these are the advanced fire protection system designed to detect smoke at an early stage, thereby providing timely warnings and help to minimize the risk of fire damage. Okay, good to go, friends. Okay, so to add some more on this HSSD, these are all the specialist fire alarm system. That is why I say advanced fire protection. So that is extremely sensitive to the smoke particle. That is the point. So you may ask how it works actually, right? So it works on the principle of series of tubes in the roof of the building with holes in those tubes, and the air is sucked through those tubes down to the filter, down to the detector module, which then analyze those particles and can differentiate between smoke and dust. You got it, friends? So this is a specialized fire alarm system, HSSD. It works on a principle of a series of tubes in the roof of the building with holes in those tubes, and air is sucked through those tubes down to the filter, down to the detector module, and then it analyzes those particles and can differentiate between smoke and dust. Very simple. You got it? Very good. Now, second item, ionization. Okay, ionization smoke detector is a type of smoke alarm that uses ionization technology, right? Very simple. So it uses ionization technology to detect smoke particles in the air. So how it works actually, it has a radioactive material and also ionization process actually. Okay, so in radioactive material, it contains a small amount of radioactive material. Typically, we call it as americium-241. So this is placed between two electrically charged plates. You know how it works? So it contains a small amount of radioactive material, typically americium-241, placed between two electrically charged plates. And the processor, ionization process, okay? So this radioactive material, whatever is kept inside between the two electrically charged plate, ionizes the air, okay, creating a flow of ions, meaning charged particles between the plates. Then how it detects? So when smoke enters the detector, it disrupts this flow of ions. You got it? Thereby reducing the current and triggering alarm. Very good, friends. I repeat again. Ionization is a type of detector smoke alarm that uses ionization technology. How to detect the smoke particles in air? Okay, so it works based on radioactive material ionization process. So what is this radioactive material? It is typically americium-241 placed between two electrically charged plates. Okay, so this radioactive material ionizes the air, creating a flow of ions between the plates, right? Then when smoke enters the detector, it disturbs this flow of ions, that is charged particles between the plates. You good to go? Yes. So sorry, when smoke enters the detector, it disturbs the flow of ions, thereby reducing the current and triggering the alarm. So that is how it works actually. Okay. Ionization smoke detectors are particularly, friends, effective at detecting fast flaming fires. So that is the point. Fast flaming fires means, flammable liquids or paper. Okay, right. However, they are more prone to false alarms. So that is the problem from cooking fumes or steam compared to photoelectric smoke detector. Okay, when we compare to photoelectric, this ionization is bit of a problem, right? False alarms. Okay, then we go to the photoelectric. Okay, as we all know, photoelectric detector is a device that uses light to detect the presence, absence, or distance of an object. Basically, it uses a light detect the presence or absence or distance of an object. So it typically consists of a light transmitter, probably infrared, okay, and a photoelectric receiver, okay. So when an object interrupts or reflects the light beam, okay, the detector senses this change and triggers an action, such as, sounding an alarm or stopping a machine, etc. Okay. So this is the principle, very simple, right? So photoelectric detectors are commonly used in, smoke alarms or industrial automation or security system. Okay, for example, smoke alarm. They detect smoke by sensing the light scattered by smoke particle. And industrial automation, they help in detecting objects on production lines. And if we talk about security system, they detect unauthorized access by sensing the interruption in a light beam. You got it? So this is about the photoelectric. Okay. So under smoke, we have HSSD. What is that HSSD? Sensitivity Smoke Detection System. Okay. Then we have ionization and we have a photoelectric. I hope you got some insights on those. Now we go into the flame detector. Okay. So flame detector, we have a UV, ultraviolet, right? So UV flame detector or specialized devices used to detect flames by sensing ultraviolet radiation emitted during combustion. So these detectors are highly sensitive, and it can detect flames within milliseconds. That is the beauty. So thereby making them ideal for high risk environment where early fire detection is crucial. You got it? Ultra flame detector. Then what is the features actually? That's what, as I said, fast response time. It detects the flames as little as 3 to 4 milliseconds. Just imagine. Then false alarm detection. They often include a time delay of 2-3 seconds to minimize the false alarm. Okay. So that is the beauty. Then wide range of detection. They can detect various flammable fuels, including hydrocarbons, sulfur, ammonia. So these are the, features actually. When we talk about the application, of course, industrial safety used in oil and gas facility, chemical plant, all these, and of course used in aerospace, employed in aircraft and spacecraft to detect fires and engines, and power generation also used in power plants to monitor the fires in turbines and equipment. So this is about the ultraviolet. Okay. Then IR means infrared flame detector, right? So these are the devices that detect flames by sensing the infrared radiation. There it is ultraviolet. Here it is the infrared radiation emitted by hot gases produced during combustion. Okay. Same as that. That is ultraviolet. Here is infrared. So these detectors are highly effective in identifying fires, especially in environment where quick detection is crucial. Okay. So same as this. Okay. Good. And talking about the key features, of course, detection of IR radiation. Basically, it monitors specific IR wavelength emitted by flames, typically in the range of 4.3 micrometer, which is the characteristics of hydrocarbon fires. So, it basically detects the IR radiation, typically in the range of what you call 4.3 micrometer. And flicker detection. See, basically, this IR flame detector often rely on the flickering motion of flame to distinguish between actual fire and other sources of radiation. So that is also one of the feature. Then false alarm reduction. See, it has advanced models, algorithm actually to minimize the false alarms. Okay, right. Application as usual, industrial safety in oil and gas, power generation and aerospace, friends. Okay, and we have IR3 also, IR3 actually. IR3 flame detectors. One moment. Yeah, UV IR. Okay, that is the same thing. Then we have IR3 actually. IR3 basically is advanced device that use three infrared sensors. Basically, IR3 means three infrared sensors to detect flames. So these sensors monitor three specific IR wavelength bands and compare their ratio to identify the presence of flame. Okay. So when we talk about the key feature, basically, as I said, it's a triple IR sensor. The three sensor focus on different IR wavelength, typically around 4.4 micrometer. Okay, right. Then, of course, high sensitivity. This detector 1 feet square, 1 square feet gasoline pan fire at a distance about 215 feet, so approximately 65 meters in less than 5 seconds. Just imagine high sensitivity. And also it has a false alarm immunity. So they are designed to ignore the constant background IR radiation and other non-flame IR sources, thereby reducing the likelihood of false alarms. Then, of course, the fast response time. It responds to flame within milliseconds. Okay, got it? So application-wise, again, it's industrial safety, power generation, and aerospace, friends. Okay, you got it, friends? So now, so far we talked about smoke detector and flame detectors. Now we talk about the heat detector. See, under heat detector, we have a rate of rise, rate compensated type. See, what is this rate of rise heat detector? It's basically a type of fire alarm device designed to respond when the temperature in its environment increases rapidly. That is the beauty. So let us see how it works. So basically, as I said, it's a rapid temperature detection. What is this rapid temperature detection? It triggers an alarm when the temperature rises by a certain rate. Certain rate in the sense typically 6.7 to 8.3 per minute. 8.3 degree centigrade per minute. Okay. Rapid temperature detection. That features is there. So again, I repeat, this is a type of device designed to respond when the temperature in its environment increases rapidly. Okay. So having said that, rapid temperature detection. So it is basically triggers an alarm when the temperature rises by a certain rate, typically 6.7 to 8.3 centigrade. Then dual sensor. So it is equipped with two heat sensitive elements. One monitors the ambient temperature, another detects the heat from the fire. Okay. Then also we have a combination model. Some detector combine the rate of rise and fixed temperature detection, providing a more comprehensive fire detection system. So these are some of the features. When we talk about the advantage, of course, faster response. Basically, it's it detects fires more quickly than fixed temperature detector because it responds to the rate of temperature increase rather than waiting for a specific temperature threshold. So that is a point. And of course, it helps to reduce the false alarms. Okay, good. So this is about the rate of rise compensated. Okay. And also we have a fixed type of heat detector. What is this fixed type? See again, it's a type of device that activates when the ambient temperature reaches a predetermined threshold. That is what. So how it works? So basically it has a temperature threshold. See, these detectors are designed to trigger an alarm when the temperature exceeds the specific limit. For example, 57 degree. Okay, for example. So then we have a bimetallic element. So many fixed detector uses a bimetallic element that bends or deforms when heated, closing the electrical circuit and triggering an alarm. So this is how actually, and it also has a thermal lag. So there is a slight delay in response due to the time it takes for them heat to transfer the sensing element. So what is the better advantage is the rate of rise. This fixed temperature has a thermal lag. So that is the point. When we talk about the advantage, again, reliability, is good and because, less prone to false alarm and also low maintenance basically for this application. Yeah, of course, it's used in industrial settings such as, boilers, kitchens, garages also, and of course, used for the residential area also. So this is about the heat detector. Then we also have a frangible bulb sprinkler system. Frangible bulb sprinkler system. So basically, this frangible bulb sprinkler system heat exchanger is a type of fire sprinkler that uses a small glass bulb filled with a heat sensitive liquid to detect and respond to fires. So how it works actually? Okay, we talk about how it works. Basically, it has features like glass bulb. The bulb contains a liquid that expands when heated. Okay, as the temperature rises, the liquid expands until the pressure causes the glass to break. Okay, then activation temperature. So the bulbs are designed to break specific temperature. For example, 57 degree. Okay, when the bulb breaks, it releases a plug that allows the water to flow through the sprinkler and onto the fire. So these are the key features. And yes, that's it. And when we talk about the application, it's used in commercial building, industrial settings, and residential settings also. Okay, friends. So this is all about the fire and gas detection system part 1. Okay, let's focus on the remaining aspects related to detection system. Sorry, yeah, detection system such as catalytic gas detector and what else? Point type detector, open path detector. All those things will focus in the second part. Okay, thanks for watching, and if you feel that the video is useful to you, you can show your support, friends, either by pressing the thumbs up button or by pressing the by subscribing, or if possible become a member. Thank you, take care, bye bye.